Guys, today we're gonna perform the examples about chapter 9 of the course under the title of Shelf Life of Foods and its Quality Determination. We're gonna solve 4 examples and we're gonna start by the first one, which was assigned for you to do as a homework. So the example says a breakfast cereal has an initial moisture content of 2.5%. I'm gonna read and I'm gonna write the given below. The critical moisture content is 8% due to the loss of crispness. We have the equilibrium moisture content at 25 degrees Celsius, 14.8%. I have the pseudo-equilibrium moisture content M'(E) is 11%. I'm gonna see the difference between this and the moisture equilibrium ME in the upcoming slide where it is written in the figure in the graph. The slope line B is 0.147 gram H2O per gram of solids. We need to calculate the shelf life of the cereal if it's packaged in a bag of 15 micrometer LDPE, low density polyethylene, or 15 micrometer oriented polypropylene, and the weight of the dry cereal in the package is 400 gram. The dimensions of the bags are 20 times 30. I'm gonna calculate the surface area. It would be equal to 600 centimeters square. Converting it into meter, it will be 0.06 meters square. The packaged product, it will be under the following storage conditions: 25 degrees Celsius temperature and relative humidity of 75%. Okay, over here I have the graph that I mentioned before. You can see the initial moisture content. Where is the mouse? Okay. You can see the critical moisture content where the shelf life have been achieved, and we have over here the equilibrium moisture content and the pseudo-equilibrium moisture content. The pseudo-equilibrium moisture content we are going to refer to it for calculating the package of the shelf life as is written in the graph, and because we need to have a better estimation of the shelf life of the food, regardless of the normal equilibrium moisture content that would be obtained under the storage conditions. Okay, so let's start. By this, we have two equations. I have written the given over here while I was reading, and I have calculated the surface area, the temperature conditions, and all the given that was provided inside the question. We have two equations that we have to take into our mind. The first one is ln ME minus MI over M equilibrium minus MC critical moisture content equals P over X times A over W times P0 over B theta S. ME equilibrium moisture content, initial moisture content, equilibrium moisture content, and the MC the critical. P over X is the permeance factor, where P is the permeability of the foam and X is the thickness of the foam. A is the surface area of the foam. W, the weight of the food that is packed inside the foam. We have the P0, it is the pure vapor pressure or vapor pressure of pure water at the respective storage temperature, regardless of the relative humidity. Okay, and then we have B is the slope of the graph, and theta S is what we need to figure out, which is the shelf life. So we have actually from the given over here, we have all the values except for the permeance factor. We need to calculate the permeance factor. How can we figure out the permeance factor? Before this equation is in slide 16 and 17. The permeance factor, we can actually get it out by the following equation. vector S equals the permeance factor surface area over P1 minus P2. This is slide 14. Theta W over delta T is the rate of gas or water vapor transmission rate. Okay, so it is either rate of gas or water vapor transmission rate of the film. P over X, the permeance factor. As we said, we have the A, the area of the package according to the package dimensions, and we have P1 minus P2 is the difference between the partial pressure outside and the partial pressure inside. So it is delta P, which corresponds to the driving force of pressure. We need to get on the P over X, which is the permeance factor.